Hello everyone, my name is Chidowere Jombu, your presenter. Um, in today's class, we are going to look at conservation of linear momentum. Of course, we know that uh, momentum is the product of mass and velocity, while linear involves anything happening along a straight line. So, the conservation of linear momentum will be discussed mathematically and in a figurative manner. Therefore, we are going to uh, define it this way that the principle states that in an isolated or closed system of colliding bodies, that the total momentum existing in such a system is conserved or is constant. So, in a system where there are isolated bodies, what it means is that when these bodies collide, it is saying and meaning that the total momentum existing in such a system is the same, is conserved, or is constant. Now, we can still put it this way that on conservation of linear momentum, that when two bodies, when two bodies, let's say A and B, when these two bodies, when they collide, that the total momentum before collision and after collision is the same or are equal. Therefore, we can now say in an isolated or closed system, system of colliding bodies, the total momentum is conserved or constant. Furthermore, when two bodies collide, furthermore, when two bodies collide, the total momentum before collision is equal to the total momentum after collision. So, if two bodies, when they collide, their momentum before the collision is equal to their momentum after collision. And this principle of conservation of linear momentum can be mathematically stated or represented as follows in respect to or with respect to three conditions. And what are those three conditions? Those three conditions are: one, when these two bodies of masses m1, m2 of initial velocities u1, u2 and final velocities v1, v2 are moving in the same direction. That is one condition. Second condition is when they are moving in opposite direction before collision and move in the same direction after collision. Then the third condition is when these two bodies of masses m1, m2 are moving in opposite direction. So, first one, let's consider when these two bodies are moving in the same direction. Condition: when they are moving in the same direction. So we have it as like this: M1, U1 plus M2, U2 is equal to M1, V1 plus M2, V2. This is when the two bodies are moving in the same direction, where this is our mass of M1 body, this is the initial velocity, this is the second body, this is its initial velocity, this is final velocity, this is final velocity. So now, second condition by principle of conservation of linear momentum now will be when these two bodies, before colliding, they are moving in opposite direction, and when they collide now, they start moving in the same direction. Now the equation will look this way: m1 u1 initial velocity minus mass of the second body, then its initial velocity is equal to, now this is in opposite direction, this is now when they start moving in the same direction. So this is condition when the two bodies are moving in opposite direction before collision, and after collision they start moving with this. Then the last one we are going to consider vividly is when these two bodies are moving in opposite direction. It becomes this way. This is in opposite direction. Opposite direction. Then we have that the equation will be this way now: m1 u1 minus m2 u2 is equal to m1 v1 minus m2 v2. So you can see, so these are the three conditions which this principle of conservation of linear momentum is mathematically explaining to us. So this is where we are going to draw the curtain close for this class, and we are going to meet in the same class in our next class. Then we will now talk about two classes of collision, or two types of collision, and of course we still define what collision is. Thank you, and God bless you, and have a wonderful day ahead.